Hey guys, good morning. I'm audible to you. Sorry for delay. So he's your senior batch. He has some interview today. Interview on deep learning, machine learning interview cleared. So he's saying that interview questions are on how the algorithms will work, explain the algorithms, and how can you import the algorithms using Python. Like that, they are asking the question stream. Now tomorrow deep learning. So deep learning is a little tricky, no? So that's why he came today. Explain the algorithm. Pakka. After you explain the algorithm, they will ask you about Python code. How can you import? How can you do it? That is. So that's why whatever we are learning, this mathematics is very, very important. And that internship, I will give that. What you need to do that? I have gone through that internship. I hope we divide to three parts that internship. Okay. That is, one is the regression problem, one regression problem, and one classification problem, and one NLP problem. So in the regression problem, we have a house prediction data set is there, right? Is there, that data? House prediction. And classification problem, email spam. Is that there? Email spam, where it is a spam email or not? Not spam. And third one, fourth one is a sentiment analysis. These three are there. Can you please confirm the chat? Now pick these three: house prediction, email spam, and sentiment analysis. These three. Emails, house prediction is a regression problem. And email spam is the classification problem. Saturday, if time permits, we'll start the Python code of this. Python code of regression problem. Regression problem, we'll do that. And next week, anyhow, we will do all these things next week. Next week, we'll do Python codes of all classifications. Python code of all classifications. But I will share all these three codes today only. Today only I will share all the outputs. Okay. But that again, to get the certification, but parallelly you need to concentrate on the how we are doing exactly these exact codes. And in that exactly out of other three, how many are there? Again, 5 are there. That 5 also you need to do. That 5 also you need to do. And not only that, and you need to do the hackathons, and that also parallelly you need to practice that. But meanwhile, that EDA part you can start that, no? EDA part. That means, you know, right? Before applying the machine learning model, that data should be numerical, right? Ultimately, that EDA part, you can do that. Major EDA part. Reading the data, any pre-processing is there, do the pre-processing, checking that missing values, checking the outliers, and next convert into numerical to categorical, apply the correlation. These all these things you need to do. The major parts. So what are the major part? Can you tell me now? First one is read the data, and very important thing is the check missing values, and third one is the outlier analysis, and fourth one is the apply some that regression problem, right? So apply some correlation thing for regression problem, correlation, and convert into numerical to categorical to numerical, cat to numerical, and apply that jet standardization. So this you can do for every data set. This main analysis. See, complete EDA they are not asking, they are asking the model development, right? So major part you can do. Complete EDA you can do by your own practice, own exploration. Because if you do the complete EDA, if you convert into PDF, that will come minimum 30 pages, right? So that is not the case. So that is doing the 30 pages and you are sending them to 30 pages code. That is not the good way. So EDA is your exploration. So they are seeing that whether you are able to develop the model or not. So before going to develop the model, you need to do these 6 steps. Any data set, these are the mandatory steps. These are the mandatory. So start immediately, read the data, check the missing values, outlier analysis, correlation, categorical to numerical, jet standardization. While you are exploring, you have done many methods, correct? But not now many methods, only one method you need to implement now. Label encoder, suppose you want to implement about the label encoder. You want to impute with, suppose median. So median imputation, filling with median value outlier. Some one method, not all methods. You know multi methods. But now when you do that, what happened? You need to do only one method. And standardization, jet standardization normalization is there. Only what we will use? Jet standardization only we will use. Understood? Start that immediately. So these 3 different problems, regression problem is one problem, classification problem, NLP problem. So you'll get an idea of 3 ways. How can we do the regression? How can we do the classification? How can we do the NLP? I think there is no deep learning problem in that. Correct? Anything kind of images problem is there? What is there? The image classification is there. That is the 4th one is the image classification. But you need to do only 3, huh? You need to do only 3. You don't have a sentiment analysis problem? So you have only image analysis. Then first 2 you have. That is only sentiment analysis. Movie review classification. Acha. So email spam is not there for you. Not for you. I'm not asking Saurav. Your name is not Shravani, right? Don't be chorus. Let's wait what. Now confirm me how many have exactly like this, how many are not. Tell me the not people. Tell me the not people. Only one person. Only one person. So instead of NLP problem, you need to do image analysis, image classification. And instead of this classification problem, you need to do movie classification. Movie classification. That you can do. So I hope I will share this all the codes. 1, 2, 3, 4, 5. 5 codes I will share. ठीक है सौरभ? Good. चलो. So we are stopping at nowadays so much work is there in office work, you know. Hell out of work. Very, very tough to manage nowadays. Yesterday I skipped the evening class because of the work. We are in the call 3 hours. Where is that Navy base? In which where I kept Navy base? This weekends I need to set up everything. Acha, I'm keeping here. Again, I'm repeating, mathematics is very, very important. So I request you to everyone, you need to learn about how linear regression is working, and to learn about how logistic regression is working. I need everyone should perfect in these explanations, decision tree, and now in the Navy bias. You need to be perfect in the explanations of each about mathematics and every question to give the answer. So that guy, they are asking them to explain about decision tree algorithm. If somebody asks you explain about decision tree algorithm, how can you explain that? The steps, entropy, gain, what is the drawback of gain, why you are going to gain ratio, and what is another method, Gini method, what is the formula, that what is the Carter algorithm, everything you need to explain. And other than this, again, they will ask you that separate questions, the separate questions are coming like this again, bias and variance trade-off, separate question. And how can you find the coefficients? What are the methods of coefficients? What is the overfitting? What is underfitting? This kind of question they will ask you. And again, out of separate, again, that metrics also they will ask you. Metrics will not started. But algorithm is how algorithm is working different. How machine learning is impacted is different. How the metrics is different. Decision tree is algorithm, but your machine learning model is impacted with the overfit and underfit and normal fit, bias and variance trade-off. And what are the different way of find the coefficient? That's the machine learning impact. And once you apply these algorithms, then which algorithm is better? That is again metrics. So these are the three parts you need to look into: algorithms, machine learning impact, and again the metrics. That is three are different. So here, so now onwards you need to look. I hope these four are the main mathematics is there. Remaining are not that much mathematics. This four only as mathematics is more. And remaining mathematics, some people will not able to understand also. That's why they will not concentrate on that, frankly speaking. But we will cover in the class. But that mathematics is little more difficult now. That is little more difficult. That's why it is now, you can say that second part of machine learning, that is called SVM, support vector machines, boosting algorithms. That some mathematics is some difficult, but we will cover. I will give my best. But in outside industry, they will concentrate on this mathematics more. Logistic and linear, everything is important. Everything is important. So let's see now. We have some drawback is there in the. We have a drawback is there. Drawback is there in the Navy bias. Navy bias. The drawback is this one. When student equal to yes, suppose there is no value of student equal to yes, 0 observations are there. Under y equal to no, under y equal to no, under y equal to no, you are checking student equal to yes. You are checking student equal to yes, but that observation is not there. But that observation is not there. But the observation is not there. So your probability now what will happen? 0. Probability what happen? 0. And when probability is equal to 0 and you are multiplying here these values, these four values now, in that this value is become 0, then entire become is what happened? 0. Now the answer will be biased. You no need to search for, even if you are finding a no case s equal to 0, then what is the another answer? He buys the computer. He can directly say, without do any calculations, you can say. That is the drawback. Correct? You are seeing no here. Under the no, there no S category. Then what will happen? 0. Then automatically, what is the final answer? 0. Automatically, what is the final answer mean? This is 0 means, then what is the other answer? Yes is the answer. So without doing any calculations, you can say that, the answer is he buys the computer. He buys the computer. Without doing any calculation means this you are not understanding any pattern. The pattern understanding is not there in this algorithm. This algorithm is completely a useless algorithm. You are not doing any calculation. No, you are searching for one observation. That observation is giving 0. Then entire mathematics is 0. That your 0 means this is the answer. Your 0 means this is the answer. So that means this is the pattern understanding is not there. Are you getting what I'm saying? Can you please confirm the chat? Can you please confirm the chat? So to avoid this, we use a technique is called Laplacian correction. Laplacian correction. What the name is called? Laplacian correction. Laplacian correction. So now you are saying that under no category, student equal to, what is that, Manu? Under no category, what is we are searching for that? Student equal to yes. Under no category, student equal to yes. ID number 6. ID number 6. Suppose ID number 6 also, suppose no is there. ID number 6 also no is there. Now tell me, under no category, how many student equal S is there? No, nothing is there. You getting? So these kind of cases might be possible in the future. So we will need to avoid that case. That means simply Laplacian is saying that add extra observation with that value. Add extra observation with that value. Now think like that. Here one example is there. You can read it, you can say that, you can easily understand. Now see here, suppose now you buy a computer class Y, how many observations are there? 1000 observations are there. Look at the screen very closely. 0 or income is equal to low, 990 or income is equal to medium, 10 equal to or income equal to high. So he is creating an observation like this. Suppose assume that a data has 1000 observations. 1000 observations. In that income is equal to low and income is equal to medium. Income is equal to medium and income is equal to high. There are three are there. Income equal to high. So income equal to low is saying that there are no observations. 0 observations. How many observations? 0. Income equal to medium. Assume that here 10 observations are there, or 990. Suppose 990 observations are there, and remaining how many are there? 10 are there. Remaining how many are there? 10. Now he's saying that now probabilities. Now probabilities, what is that now? Now if you take the probability, that is equal to 0 by 1000, and here what happened? 990 by 1000, 990 by 1000, and here what is happening? That is equal to 10 by 1000. So 990 by 1000, how much is the value now? 0.99. 10 is equal to how much is the answer? 0.001. Correct? Now his idea is this getting 0 right, then add observations, add a new observation. Income low is there. Income low is there. Add one more extra observation. When you add extra observation, how many total observations now? 1000 plus 1, that is equal to 1001. That is equal to 1001. So to avoid the bias, add income equal medium also. To avoid the bias, he's saying that add income is equal to medium also. An extra observation, you add it. Extra observation, add medium also. Add it. To avoid bias. To avoid bias. Because you are adding only this guy, then this guy will ask you, know, why you are not adding me? Your model will be biased. You are concentrating on only on some observations. That is not good. You should not concentrate only on the one observation. Now, how many observations now? 1001 plus 1, that is equal to 1002. And similarly, add income equal to high also. Again, add it to avoid bias. Now, how many observations now? 1002 plus 1, that is equal to 1003. Because the three labels are there, you are adding a 3 extra observations. Under income, how many labels are there? Low is there, medium is there, high is there. That's why you are adding how many extra observations? 3 observations. You added low, you added medium, you added high. Is that clear? Any doubts? Can you please confirm the chat? Is that clear? Utkarsh is good, Priyanka is good. What about others? You're adding extra observations. Now the same story. Now same story. New probabilities. Come to the new probabilities. Income is how many observations are there now? 1. Medium, how many observations are there? Extra. High, how many observations are there? Extra. Understood? But what are the total observations now? 1 by 1003, 991 by 1003 and 11 by 1003. Can you tell me what is this answer? What is the answer? 0 0.00. What is the answer? 0.009, 3 times 0, 9. This approximately how much? 0 only. Approximately how much? Is this any impact is there? Do you think this is a much impact or less impact? Much impact or less impact? This is how much? This is how much? 0. That means that is the base, but that is not impacting. You're adding the extra observation because your mathematics is failing. Even though if you add also, that is not impacting your entire model. And this is called the Laplacian correction. What is called? Laplacian correction. Are you getting, ma? So this is a 0.9880. This one 0.9880. And this one, what is the another answer? 0.010. Same thing is coming. Now, even though we add an extra observations, the probability values, the probability values are not much deviated. So with this correction, the model will not impact much. but we can avoid failure of maths. Failure of maths. Hmm. 1000 plus 3? That one 1003. बोला मा? Sorry, I miss. One only, na? बोलो. 1 minute.1 minute, ma. Is that clear, ma? Laplacian correction. So now I have best 2 important questions. First question is, what is the assumption? Second is, what is the Laplacian correction? Second is the Laplacian correction. And third one is, you tell me, what are the hyperparameters? Hyperparameter in Navi bias. That is the question for you. This question is for you. What is the meaning of hyperparameter? Follow. Shravya. What do you mean by hyperparameter? I will hit you if you doesn't do this. What is the parameter? What is the hyperparameter? Hmm. Hmm. Very good. Hyperparameter meaning what? Bolo answers in the chat. Hyperparameters are the parameters the user can change to get better accuracy. Better accuracy. And that we call tuning. So what is the assumption? What is the assumption in the Navi bias? Class conditional independence. That means all the variables are independent each other. What is the Laplacian correction? Extra row. When you will add extra row, if observation has any particular observation has 0 value and that is failing our algorithm, then we are taking that. Let's see. Assumption in Navi bias. The Navi bias classifier assume that all features in the input data are what? But often in the real world scenario, it is not true. The best example is the health data. When you take health data, all the data is interlinked. Correct. Whatever the health problems, everything is interlinked. That is the independent things. But it is efficient and good performance because it's completely a logical way, right? It is a completely probabilistic way, completely a logical way. Instead of saying that machine learning model, it is a kind of a statistical model. The kind of a statistical model. That is a Navi bias. So, and one more thing is called Laplacian correction. Laplacian correction. Improve the Navi bias. That a Laplace smoothing a technique prevents zero probability. Prevents zero probability. So after the class, you need to read the textbooks because some people so much worry about the interview questions. Okay. So you need to make your own definitions. You know the concept, you can talk by your own. But if you're a little bit confused on the communication wise, you're not able to explain the proper word, then what you need to do immediately? Take a fresh book, take each and every algorithm, note down all interview questions. Anyhow, I will share, but you know the concept, right? On that particular day. After going home, revise it and make your interview questions. What are the important topics in that? So generally, you know, in IES or IAS, the daily revision is very, very important. What they will do? They'll revise daily. They'll revise daily. Let's see some interview questions. We'll be able to do that. So the first question is, what is the basic assumption? First question is that only. And you know what is the basic assumption, correct? Pakka question. If you put in your resume Navi bias, first question is that only. What is the assumption? What is the assumption? What are the possible advantage choosing the Navi bias? Okay. And less training data, that you can say anything. These are the not true. Okay. This is their assumptions only. These are not true. What are the disadvantages? Because independent, that is the disadvantage. And one more thing is, what is the disadvantage? Zero probability. And you know, features are highly correlated. You can't avoid that sometimes. Okay. You got with BP, what you got? Suppose some heart attack you are getting, suppose, think like that. You can't avoid those, right? You can't avoid those. Sugar like that. Is feature scaling required for Navi bias? That is the feature scaling. Feature scaling is required for most probably every algorithm is required. Feature scaling. Feature scaling will avoid what? It will avoid complex mathematics calculations as well as all the features are under the one root. But why this question is asking? Because you are saying all the features are independent, then is that really required to do that, sir? That is the question is asking. Are you getting why this question is asking? Is feature scale is required Navi bias? First of all, feature scaling. Feature scaling means what? You are scaling the observations. You are scaling the all feature observations under one roof. Under one roof. That means there two options are there. One is the standardization. Standardization. When you do this, all the observation values are -3 to 3. Irrespective of one observation is very high, irrespective of one observation is very low, but your values are -3 to 3. And what the second one is there? Normalization. Normalization will give what? 0 to 1. And you are saying that features are independent. Features are independent. And is this required? The scaling is required. That is the question. Scaling is required. That is the question. That is a very good question, no? This kind of question they will ask you. Okay. If you read the article, if you read the textbooks, then you will get the understanding all these things. This is a very, very good question. That is, feature scaling is very, very important for each and every algorithm. And why this asking is, even the probability also, whatever you are getting, the probability, if you observe here, the probability is based on frequency of observations. Frequency of observation. That means how many observations are there, not the value, not the value. Not the value. Quantity I am not seeing. That quality I am not seeing. Quantity only I am seeing. Even though the salary greater than 10,000 I am concentrating. Whether you are getting 1 crore or 2 crore, I am not mind that. In this model, you are not concentrating on the values. You are concentrating on how many times it is repeating. How many times it is repeating. That's why he is asking this question, is feature scaling required? Like that. So in order to say that, you need to think all these things. What is happening in the inside the algorithm, that each and every minute point you need to think. What is happening in the logistic regression? What is happening in the decision tree? What is happening in the Navi bias? How three are interlinked? How three are differentiate? That is everything you need to take care of. There are probability. Three algorithms, somehow they are using probability only, no? Logistic regression, logs, probability. And decision tree, entropy, probability. Navi bias, probability. Ultimately, machine learning model will give what? Probabilities only. Every algorithm, probability. So this way you need to think about, man. This is, I'm just giving the idea, but if you see it and you can discuss, you'll get so much ideas, that is. Understand? Every scientist are very, very greatest scientists and they're implementing the beautiful mathematics. Impact of missing values. Definitely that is the impacting that missing values. Missing values, you can't get the good conclusion, right? The values are missing. Impact of outliers. What are the different problems? They all are classification problems. Sentiment analysis, spam classification, Twitter, document categorization, Navi bias. This document categorization is a very, very important use case, Navi bias. Which document is, that is, one document is horror document, one document is thriller document, one document is the story. the story, document categorization. Every time after that, I am opening, why I am opening this? At least one person will go through these articles. Why sir is opening every time after algorithm is covered? At least you will go and you will start reading that. That is. So do that, make that as a habituate. Make that as a habituate. Okay. So chalo, next algorithm. Next algorithm is very, very easy algorithm, a dead algorithm, that is. Anyone can find, that is. And the algorithm is called K nearest neighbors. KNN. 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 That is called K nearest neighbors. K nearest neighbors. K nearest neighbors. K is a number. K is a number. So generally it will work like this. Closest relation. Closest relation. And far relation. Closest relation and far relation. When I say closest relation and far relation, immediately you need to get the strike of the mathematics. The math is called distance metric. Distance between 2 points. Distance between 2 points, and the name is called, you know, what is the distance between 2 points? Tell me. Euclidean distance metric. Euclidean distance metric. The main name you might not know, but the formula you know, the formula what you said is correct. Okay, there are 2 points are there. There are 2 points are there. One point is x1 comma x2, and another point is y1 comma y2, x1 comma x2, and y1 comma y2. You know that is, look at here. So this is one y-axis, and this is the x-axis, and this is the point. X1 is the point, and this is the x1 is the point, and this is the x2 is the point. So x1 and x2, and this is the y1, and this is the y2. So this point will give what? X1 comma y1, and this point is what? X2 comma y2, and you need to get the distance between these 2 points. That means x1 comma y1 distance and x2 comma y2 point distance. These 2 points you need to do. In the 2D space, you want a distance between these two. I think I need to write x1 comma y1 and x2 comma y2. Then look at very, very carefully. This one. This is the x1 and this is the x2. What is this distance covered? What is this distance covered? X2 minus x1 is the distance. Correct? Correct, Avesh? And similarly, this point and this point, what is this distance? Y2 minus y1. Now you want this k. Your Pythagoras theorem, hypotenuse square is equal to side square plus side square. What is one side square? One side is what? X2 minus x1. This is the proof of the algorithm. X2 minus x1 whole square plus y2 minus y1 whole square. The k, the root over, this is the formula. Okay, that's the formula. Formula is very easy, but you need to explain the same thing to your kids tomorrow. Okay? Because they will not explain the school days, no this. They'll give directly a formula. Then you need to teach him at home. Then his mind will be wake up now. Okay, he will connect the dots. Otherwise, he will become us in the future. Avoid that. Avoid that. Yesterday, we have a fun family group is there. There some family kids are there. I given something like this. Question. The question is like this. Okay. I will just exact question. See, I'm pasting in the WhatsApp group. Same question I have given. Give me 1 minute. Very rarely I will post something in the group, in family group. So general in family group, what they will post all, shorts. So data science October and data science 9 AM. I posted. So that is the question. Find the mistake in this, what's wrong. Okay, A, B, C, D, F, G, H, I, J, K is there, that is the answer. You can tell me what is the wrong in that. That I posted to my kids. They are saying that ABCDs are wrong. Find the spelling is mistake, that is. They are not concentrating on that. They're concentrating on ABCDFGH. They're saying that R is wrong, bye. L is wrong, bye. Like that, they are saying that. So good time pass has happened like 2 days before. But that kind of questions, very, very important to kids. Not to you. Now the idea is like this now in this algorithm, the idea is suppose a two-dimensional space, you have a data will be like this. These are the data points. The data points, some S category and some no category. What you are seeing is the red is the another category. Okay. This red is nothing but some kind of a no. Label what? No. And what is the black is called label? Yes. A new observation is falling somewhere like this. Now this guy should go to no category or yes category. That you need to find. That is the machine learning use case, correct? That is the machine learning use case. Now here and then what your idea is, you want to find this guy to distances of this. Each and every distances. Each and every distance. The more you distance, more is there. the relation is less. The more your distance is less, the relation is more. That is the concept here. That is the concept. That's why this is a very, very easy algorithm, and the people call this called very, very lazy algorithm. Why lazy means it will not able to understand any patterns. It's direct mathematics based. No patterns. Just calculate the distance, and then whichever is the lowest distance, he is the answer. I will go with him. Simple. Who is very, very closest to me? I will marry that guy. Simple. Who is not closest, I will not marry. Like that. Simple. But when you do marry, you will search for only one boy or one girl. You will see different guys, right? That is called K. How many members you will search? 3 members or 4 members, 5 members. I search a lot of girls. 2 years. And finally I found one girl. That is called K. So how many neighbors you want to concentrate? That now suppose there's around your neighbors are there. Maybe in that neighbor, no guy also there and yes guy also there. No guy is there and yes guy is there. So that is the tricky here. So comparing these neighbors, then whichever is the closest and you will go to with that guy. Simple marriage proposal. Same. Search for some guys, whichever is the closest and marry that guy. Simple. Same operation here also. And now you understood right now K means? K is a number and that is called the hyperparameter chosen by user only. How many numbers you want to choose. So let's do some problem, then you will understand that easily. So this is the problem. So x1, x2 and y, the simple problem. So I will just take this problem now here. Yeah, note down the problem. X1, x2 and y. 1, 2, 3, 4. So x1 is there and x2 is there and y is there. X1 means what happened here is one feature and second feature and the output. Okay. And here 7, 7, 7, 7 and is a bad is there. The output is bad is there. And here the output is 7, 4 and that is also bad is there. And that is 3, 4. The output is good is there. And 1, 4, that output is good is there. And now question is, a new guy is coming, this observation, and new tuple x1 equal to 3 is coming, x2 equal to 7 is coming. What should be y? What should be y? Understood? Question? Data understood? Now this is a machine learning problem. Old data and new tuple. Now for the first step, step 1 is calculate distance. Calculate distance between each observation. Between each observation. And the distance formula you already know, that is the distance formula. What is the distance formula? That is equal, I am writing here, root over x2 minus x1 whole square plus Array. I will write like this. X2 minus X1 whole square and plus Y2 minus Y1 whole square, the formula. Now you are applying the same formula for these calculations. First observation is 7 comma 7. 7 comma 7. And what is that next observation? 3 comma 7. Similarly, another observations. All the observations, can you write it? Four observations. Don't calculate the root value because without root only we can say that. Tell me this value 7 comma. What is this value, ma? 7 comma 4. 7 comma 4 and next value 3 comma 4, next value 1 comma 4. And what is this now here? X2. What is X2? 3. What is X1? 7. And what is this? 3. And what is this? Oh, it is 7. Huh? 7 minus 7. Below here, what is 3 here? 3 minus 7 and 7 minus 4. And here, what is the answer? 3 minus 3 and 7 minus 4. And here 3 minus 1, 7 minus 4. Now quickly you say the answer here. Again, same, you no need to find the root. It's okay. You don't need to find the root. We are not concentrating on root. Without root only you say the answer. 4, root 4. Root 16. Tell me that. Because some values you are not able to find exact root, right? Root 25. Root 13. 9. Root 13. Paka? Correct, ma? I'm updating the table now. Updating the table. Updating the table. Distance metric D. What are the D values now? Root 16. Root 16. Root 25. Root 9. And root 13. Done. This is step 2. Sorry, step 1. Now step 2. Provide the ranking. Provide the ranking. Lowest distance, that is the first rank. Highest distance is the last rank. Provide the ranking. The ranking you wish, how you want to provide, that is not the matter. Provide the ranking. That the rank. Lowest distance, the 1. And next 2. And next 3. And next 4. Understood? Step 2. Easy. Can you please confirm the chat? And this is a tricky point. Step 3, choose your neighbors. How many neighbors you want to choose? Choose your neighbors. The one good point is called neighbor should be always of the odd number. Neighbor should be always in the, if you choose even number, no, you like two guys, then how can you pick one guy? That is the problem. Toss. That's why odd number. Choose neighbors as an odd number. So k is equal to 3. There are 4 observations are there. The k is equal to 3. I will tell the formula also how to choose that. Now k is equal to 3. Now who is your neighbor? First person very close there, she is his neighbor, yes. And second one is his neighbor, yes. And this he is neighbor, yes. But this guy is not your neighbor now because he is a 4th ranker. How many neighbors you choose? So top 3 only your neighbors. That's why Python will take care of. No one will ask you to write 16-mark question, no? Data definitely large. Data definitely large. Data so much large, you know. Now ChatGPT definitely large. So that is not possible with a normal human being to write all these things. Root n. The formula is root n. I will tell you that. So you are saying whether it's a neighbor or not. Question is what? Neighbor or not. That only, ma'am. Data is very large. That's why I created this all materials I created by my own to explain the students, picking the small data sets, perform the mathematics, to make them understand the mathematics, because data is definitely large. You can't implement that. That is. So now write the original answers. Step 4 is the for only S category, for only those are neighbors, for only those are neighbors, write the original label. Write the original label. Write the original label. Write the original label. Original data, original output. Why? Original. What is the original output? This bad. For this, you are not required. Don't write here. Don't write this. What is the next one? Good. What is the next one? Good. Now, 3 neighbors answers is, one neighbor answer is bad, another neighbor is good, another neighbor is good. Think like that. There's a 3-member committee is there. 3-member committee is there. Now, the final conclusion is what? Majority of voting. Majority of voting. So out of bad, good, and good, what is the majority? So your final answer is good. Simple. Out of that voting, the conclusion, the answer is good. So 3,7, the tuple 3,7 will goes to the good category. 3,7 will be under good category. And don't say out of all algorithms, KNN is the easy algorithm. Okay, don't say that. In your mindset, remove the KNN. That is. Again, I'm repeating, ma. Very, very easy. Calculate the distances with all the data points with new data point 3,7. And that is called 7,7, 3,7, 7,4, 3,7, 3,4, 3,7, 1,4, and 3, 7, you got the distances, and I made the distances. And next, provide the ranking 1, 2, 3, 4. And next, choose the neighbors k equal to 3, and that whoever neighbor, that means top 3 your neighbors, and remaining 1 is not your neighbors. And top 3, you are concentrating only in the top 3. Out of top 3 original answer, the original answer is bad and good, and the majority voting is for good only. So I will go to the good. So there's a fun discussion is going in family. So in family, 5 members are there. 3 members are saying yes, 2 members are saying no. I will go with yes. Like that. Committee, think like a committee is there, like that. But here the question is, the important question is, now you need to come with this one. When will the model will be overfit? Model overfit in this scenario? That is the first question. Very, very important question in this. When model will be overfit? And second question is how to choose K. To choose K, one is K is always a odd number. K is always an odd number. And second one is K is equal to root over n, root of n observations. Root of n observations. Root of number of observations. So in this scenario, n is equal to 4. You will apply what? 4. You will apply 4. But 4 is equal to how much? 2. And what is the first number? K is always a number. Either you go 2 minus 1 or 2 plus 1. Either you go 2 minus 1 or 2 plus 1. That is the answer. Then why we are picking 2 plus 1? Why not 2 minus 1 is the question? Tell me, 2 minus 1 means what is the answer? 1. I have only one friend in my entire life. So I will listen only to him. Then what happen? I will be overfit, bias. That means I am not able to learn. I am not able to think. I will always depends on only one neighbor. So when K is equal to 1, model will be overfit. Every interview I ask this question, ma. Only 1 or 2 persons will say the answer. K is equal to 1, model will be overfit. Very, very important. Because you are attached to only one neighbor, no? When you are one neighbor, then what happen? You are dummy minded. You are become dummy mind. That is, you never think about yourself. You always depends on particular guy. That's why K is equal to 1. You have your 10 members are there, your 1 member friend is there, 10 members friend is there. Then what happen? Better solution when will come? 10 members only. So K is equal to 1, model will be overfit. K is equal to 1, model will be overfit. Rank always start from low to high. You can provide any rank. Rank is your wish. You can change into this is, you want to change this is into 4. Then change into 4. Then you need to write the statement. What is the statement? Highest rank is nearest neighbor. Or lowest rank is nearest neighbor. That statement you need to provide. That statement. You are providing rank. Rank can be anything you can provide. You can provide ABCD also. Then A means the lowest, like that. That statement you need to provide. Understood? Rank can be anything. But this question they will ask you, ma. When will be the model overfit and how to choose K? 17, tell me. Tell me, क्या लेना? That is your wish now. But do you think only 17 observations will be there? Huh? Suppose. Yeah, that's all KNN, ma. So all basic algorithms are completed in the classification. All the basic algorithms are completed. Now we'll concentrate on the metrics now. Tomorrow metrics. And then next Python code. Again, level 2 algorithms. Again, level 2 algorithms. So next week onwards from everything is the Python. Support vector machines, bagging, boosting algorithms, random forest algorithms. That is are there. And unsupervised learning algorithms also. Unsupervised learning algorithms. Chalo, ma. So see you tomorrow. So this all basic algorithms are completed. I need the information of all these things. I think Saturday we will sit and we will practice all the algorithm mathematics. Saturday. So my students should perfect all the mathematics of all algorithms. That is my ultimate goal. Whether you by heart it, whether you learn it or remember it, I don't mind. But in interview, you need to perform that. Because if you go to other lecturers or other way, they will explain just a PPTs and they'll just gone off. So I don't want to take this much time. Why I'm taking that, you need to concentrate that. All the mathematics is very, very important. Yeah, chalo. Saturday, we will work on all these algorithms. And if you have any doubts, we can discuss that is. So tomorrow and day after tomorrow, we'll do the metrics. Metrics also will take some time. In 2 classes it will take. And then we'll practice this. Monday onward, that is a Python thing. Chalo, ma. Thank you so much. See you tomorrow.